All right. Hi, everybody. I'm Brainjar from Composable Finance. And today I'll be presenting to you our vision for XCVM, along with a general overview as to how all these different pieces fit together. So first of all, I think it is becoming clear that obviously Composable is doing quite a bit of things in this ecosystem. Our intention is to really have Composable and Picasso, both of our parachains, emerge as the first cross-chain smart contracting ecosystem. On top of that, we've also been building a plethora of palettes to be embedded directly in the runtime of both Picasso and Composable parachains. And just a very brief overview of some of these things. We're obviously working on Centauri, the first trustless bridge to the Cosmos ecosystem utilizing IBC. We're building Pablo, a DEX, along with additional DeFi primitives as palettes directly in the Picasso runtime. And we're also working on a substrate-based oracle with the intention that all of these different pieces can stack together to create one cohesive financial ecosystem to exist within the Kusama and Polkadot ecosystems as substrate-native applications. Now, XCVM is kind of this tooling that then pieces everything together and also introduces a contracting framework for logic to do so. For us, the main focus was really how can we build tooling to enable ease of use for the end user. And when we set out thinking about how can this be done in the substrate perspective, we realized that there needed to be robust frameworks to actually call into these palettes and to be able to orchestrate logic across not just our Kusama or not just our Polkadot parachains, but between both parachains and also across multiple parachains. And then, of course, because we're also focused on extending IBC to other ecosystems, also extending this communication to other ecosystems as well. So trying to figure out a way in which our technology could be extended to the outside ecosystem beyond just Polkadot led us to build XCVM. And what XCVM really intends to do is create a framework that allows for message passing and logic orchestration across multiple different blockchains with a single contract being deployed to allow for not only ease of use for the developer, but also ease of use for the end user, because obviously interesting user experiences can be built around a single contract interface. So in thinking about how to actually architect XCVM and what the problem was that we're trying to solve, I think the problem that we're trying to solve is essentially maximalism. So how can a user who doesn't know anything about DEXs tomorrow just decide to pick up MetaMask and start trading on a DEX? You're not really sure, of course, which protocol to actually interact with. You're not sure if you're getting the best rate. And I think there's a massive kind of like information gap for individual users who are new to the ecosystem. And so we wanted to orchestrate XCVM to fit user centricity first. So essentially, how can we get users to interact with an application that all they need to understand is what is happening, not necessarily how it is happening. And so looking at the technical stacks out there, we realized that, of course, this means we have to build a framework for cross-chain applications, and investigating some of the solutions out there like Layer 0, we quickly realized that these frameworks, these toolings around cross-chain, essentially glue, still resulted in the developer needing to deploy a contract on one chain, connect it to another chain, and store the logic on each individual chain. So it results in a super complex perspective to actually build one of these retail-facing applications. And so we decided to architect XCVM in such a framework where developers only have to deploy a single contract, messages are passed trustlessly using a variety of transport layers to multiple different chains. So no longer does the developer need to deploy multiple different contracts, and no longer does the developer need to store logic on every single chain. And so just kind of reiterating this a little bit more, I think there's this notion of like deploying an application natively cross-chain. When you're building something like, say, cross-chain AMM or a cross-chain lending solution like Aave, for instance, or taking Fuse cross-chain, oftentimes what will happen is a single instance of the application will be deployed on multiple different chains, but then there's no real like logic layer to connect all these different instances to do sort of higher level things like health factors or liquidation bots or monitoring of specific pools and rebalancing and all these different types of things that are sort of like traditional within the TradFi perspective. So these things are basically not possible to be able to be built with a framework, just deploying multiple different contracts, aka the multi-chain perspective, and then just gluing it all together, aka cross-chain. And so we saw this as a major gap in the market and decided to architect XCVM with the notion in mind that logic needs to be maintained at a higher level, and it doesn't matter how the contracts then basically become connected, whether that's through IBC or whether that's through XCM. So what powers all of this infrastructure we're talking about is substrate palettes. And essentially, this is what our infrastructure actually looks like. So XCVM is a contract layer that sits on top of all of these different pieces of infrastructures that are all individual substrate palettes on our parachains, and allows for essentially being able to call directly into these palettes, but also be able to do something interesting, which is be able to also call into other parachains as well. And so for the first time ever, we've now introduced a CosmWasm VM onto our chain. So introducing WASM-based smart contracting onto parachains. For the first time, this will be in production on Kusama, on our Picasso parachain. And essentially, this is the framework that we use to do all this orchestration and cross-palette calling, cross-chain calling across not only the different palettes on our chain, but also palettes and interfaces on other chains as well. So just diving a little bit deeper into how XCVM is actually architected, we've essentially taken inspiration from XCM, and that is essentially the sort of prioritization of XCM over time is to be able to pass data from chain to chain, and that we're going to live in a world where basically blockchains are talking to each other through data passing. And so we've created a messaging framework called the XCVM instruction set that can be passed from chain to chain, all from one location where the contract is initially deployed. Again, we also utilize the CosmWasm smart contracting framework, so there's obviously tons of developers within the Cosmos ecosystem who know Rust. They are now writing CosmWasm contracts for a variety of applications on Juno, on Osmosis, et cetera. And so now those developers can also deploy onto the Picasso parachain very shortly. But I think also what's even more interesting is if, say, Polkadot users want to make trades on Juno or Osmosis or any of these other ecosystems, they can now do so through XCVM by essentially interacting with a contract on our parachain that points directly to, say, Osmosis or Juno or any of these other CosmWasm-based chains. And IBC messages will be passed back and forth to do so. So just really, really breaking this down as to how this actually works from a developer perspective. So say someone wants to essentially create a contract that routes orders to the deepest DEX in the ecosystem of the chains that Composable is connected to. So the developer writes a contract and specifies a function as general as swap. Thereafter, the routing layer specifies essentially which address should the message be passed to, so which actual DEX should this interact with on the specific chain. Thereafter, messages are passed, aka the XCVM instruction set, to satellite contracts, which then interact with these respective protocols, and execution happens. So I think this is a very abstract idea of like, what does it mean to actually have logic for cross-chain orchestration and for being able to have blockchains actually talk to each other. I think now, like, we've really been struggling from the parachain perspective to create applications that actually utilize XCM in like really innovative and novel manners. And so I think with one of the major things that XCVM will do for the parachain ecosystem is now any parachain that wants to do some sort of higher order logic, like say, farm on Mangata and take those LP tokens and take out a loan on some other lending protocol on another chain, and then take that loan and redeploy it into an LBP on another chain. All this logic can now be composed in one smart contract deployed on our parachain and orchestrated across all of these different chains within the parachain ecosystem. And I think what's also interesting is we're the first team to actually bridge Cosmos and Polkadot together. So via IBC, both ecosystems will be able to talk to each other. And so now this means developers can actually build applications with parachains and IBC-enabled Cosmos SDK chains in the back end. So for the first time, both ecosystems, both classes of applications, and essentially, IBC and XCM will now be able to actually talk to each other and work together for one sort of new next generation set of applications. So I think it's important to note, obviously, what are the pieces of Cosmos technology that we are using to build this stuff. So I spoke a little bit about substrate palettes and how crucial they are to our infrastructure. But of course, we're also spending quite a lot of time bringing IBC to Polkadot. So Centauri is our initiative to connect Cosmos and the Polkadot ecosystems via IBC. And we're also bringing IBC to Near by way of Polkadot as well. And we're intending to also expand these efforts to ZK Sync and multiple other rollups and side chains. And this is really important to us because even though XCVM doesn't necessarily care about which transport protocol it works with, it's essentially bridge agnostic. One key component here to realize is that obviously some bridging is more trustless than others. And for us, obviously, IBC and light client-based bridging is, the pinnacle of trustless bridging at the moment for us. And we believe that it is like fully worth it to invest time into essentially burning down the trusted bridges that exist in the ecosystem at the moment and replacing them with trustless bridges, because I just don't really imagine a world in even 5 years where anyone's going to want to use validator-based bridges or multi-sigs or any of these types of infrastructure, because it just is also difficult for teams to maintain as well. Secondarily, we're also focused on bringing CosmWasm to our parachain. So as I said, we essentially have a palette bringing essentially CosmWasm. We've built a CosmWasm VM as a palette onto our chain. So now essentially developers will be able to, and this was demoed at Unchained, our event on July 1st. You can find the demo on our Twitter, of course. But essentially, CosmWasm is a framework that is very kind of agnostic to the underlying consensus protocol. And its tooling is, very kind of malleable and easy to understand for a lot of Rust developers. And so we decided that this would be the framework to actually bring WASM to our parachain. So oftentimes people ask me, are we deploying a new language? And the answer is obviously no. Are we deploying a new contract framework? The answer is also no. So instead of basically rewriting existing smart contracts and protocols, we're essentially creating a framework around that's essentially an add-on via the CosmWasm framework to handle state transitions, reverts, disputes. And what ends up happening is that the XCVM instruction set is essentially a set of reversible state transitions. So essentially, you'll see in the next slide, you'll be able to define state transition functions across multiple blockchains through a single instruction set. And how this actually works is basically through exposing lower level APIs to directly query and interact with the current state of the chain with respect to that specific transition function, and then of course a higher level interface that observes the full instruction set to make sure execution is being completed along this full instruction set of execution. So putting this all together, this is inspired from like the OSI model for networking, of course, that we all have experienced. And so for us, the XCVM application layer is where users would write cross-chain applications. Thereafter, you have this presentation layer, which is then basically the, once the instruction set is generated, actually passing that on to the routing layer, which decides which protocols to actually interface with. Thereafter, again, we are transport layer agnostic, so IBC, XCM, and multiple different transport protocols are used to pass these messages. And of course, the bottom layer is our infrastructure, which is our 2 parachains. So talking a little bit about what the use cases are of something like this, obviously there's tons of other cross-chain projects out there like Layer 0 and Connext, who are basically throwing around this idea of a cross-chain DEX, cross-chain lending aggregator. So if you guys want to read about those use cases, you can check those out. But I think one of the things that are, I'd like to highlight basically 2 sort of key use cases that you wouldn't be able to do without XCVM, and how XCVM basically makes these things possible. So the first thing is cross-chain Mev. So we've been talking a lot about what Mev is going to look like in the ETH2 perspective, talking a lot about like what does Mev look like within the Polkadot ecosystem. So I actually believe fundamentally that relayers that are passing messages from chain to chain, as we expect the world of blockchains to evolve, if IBC does become the transport layer that other ecosystems are talking to each other with, then this becomes like a massive opportunity for relayers to actually now make money through good Mev, not necessarily bad Mev. And what this means is instructions can be interpreted by relayers and thereafter acted upon. And I think there will also be some collusion between relayers and validators as well, where basically relayers and validators, if they work together, they'll understand what transactions are upcoming in the next block. And then, of course, that does also introduce Mev. And so XCVM empowers these different players to now actually, instead of running net negative businesses, to be able to run net positive businesses and now actually have this relayer incentivization problem solved. The second piece I'd like to also talk about is function aggregation. So I think there is a world in which everyone believes that DeFi will replace traditional finance, and I think we're obviously many, many years away from that. But one of the things that I'm excited about and why we're building XCVM is because I think the reason why people still exist in the traditional finance ecosystem is because A, it's easier, but also B, you can do a lot of very complex things because you have authorities like DTCC and others who are performing settlement and things like that. And so I think with XCVM, you'll now be able to create these complex structured products and these complex derivative instruments. For instance, you could take out a position on DYDX within the Cosmos ecosystem and then hedge that same position on UniV3 on, say, Ethereum mainnet, and then basically actually take out a loan on both of these positions on some derivatives protocol within the Polkadot ecosystem. So I think there's like these contracts, even though they seem simple, they're actually introducing brand new financial primitives. And I think these primitives are very much so simply not possible with things like Layer 0 and others that are just really serving as glue code. Is this notion of basically what can logic do for the blockchain ecosystem within the context of orchestrating functionality. And so I'll take you through a perspective of how this actually works within the loan perspective. So someone would write a XCVM contract and essentially allow for LP tokens on one chain to be deposited. A message is passed to another contract that says, hey, this collateral has been deposited, now the loan can now be taken out. And XCVMs can specify all the possible instructions all from the top layer so that you don't need to have multiple instances of the same protocol on multiple chains. And this is sort of like, I think, the most salient way of describing this, which really shows, at the top level, you have the contract actually getting deployed. You then have relayers broadcasting the instruction sets to different chains, and you see the various functions. 1, 2, 3 happens in one ecosystem, then a relayer passes the message from the last instruction and says, okay, Polkadot ecosystem, execute 4, 5, 6, 7, and then another relayer picks up the next step and says, okay, 8, 9, 10, 11 should happen in the Cosmos ecosystem. So now we're really just, it's almost like, I don't want to go as far as to say like composing VMs, because we're not doing that, but we are composing execution in an asynchronous manner across multiple different ecosystems. Now, all this sounds cool from a technical perspective, but what does this actually look like from a user perspective? And I think a lot of the things that we do at Composable sometimes don't make sense to people because of how radical we're thinking about, like really trying to serve the user first and then sort of build technical solutions around that. And that's very much so how XCVM was architected. Like we started with this and basically worked onwards to figuring out what the best possible architecture would look like. So we demoed this in Berlin at Unchained, and basically what this is showing you is a user connects their wallets, multiple wallets, through our proxy wallet, and then specifies, okay, here are the two things I have. I have Pika and I have USDC. What do I want to end up with? I want USDC on Arbitrum. I want ETH on mainnet. And then instead of specifying which AMM you want to use and what's your slippage tolerance, which you of course could do through the advanced settings, but if that's all someone wants to do, that's all they have to do. They click execute. And then from there, to make the user actually understand that there's stuff happening in the background, we then have to have what's called the sexy stepper, which basically is we're trying to think about what is the way in which people can actually understand what's happening across multiple blockchains without displaying them 5 different explorers at the same time. And so we essentially have created this like framework where essentially indentations mean you've now showed up on another blockchain, and it expands out to the explorer itself. You could also share the routes. So for instance, if you want to show people how you aped into some farm, you could also share that route of this stepper. So this stepper will evolve significantly over time, but I think it's really key to illustrate that like we're trying to get the use of money and the movement of money to feel almost as simple as just writing an email, basically. And that's why we have the word compose. You don't see the word swap here, and it's compose from and then into because of exactly that. And one could, of course, conjecture, okay, well, why don't you just do this for all functionalities? And so that's what we are. I don't have that slide here, but we are intending for this exact framework to be reusable for lending and for many other functionalities in the future. So all that being said, around the UI perspective, like we are an infrastructure project, and so we've put a lot of time and thinking into what are the pieces that someone needs to build one of these beautiful retail-facing applications. And so we're open sourcing our proxy wallet, we're open sourcing the stepper, we're open sourcing also an integrations wrapper to prevent people from having to integrate like 3 different times with 3 different ecosystems. And so obviously I talked a lot about technology all the way up to now, but I think it is incredibly critical for us over these next few years in crypto to really hone in on the 2 key pieces that we need to solve. One, preserving decentralization, right? Oftentimes we've seen all these different DeFi protocols and applications pop up because they provide a good user experience, but of course, decentralization takes a detrimental hit as a result. And then 2, of course, is user experience. I think instead of focusing heavily on, what's the most amazing technology we can create, we really need to focus on how are we going to actually make users feel delighted by these types of applications we're introducing. And with that, that's how we bring about mass adoption. So thank you.
Okay, thanks for your presentation. Are you okay to take 1 or 2 questions or not?
Yeah, sure.
Sorry, if we have, I don't know. Okay, we have one. Just a moment.
Hello, thank you for the presentation. In terms of transport layer, the equivalent of IBC in the Cosmos ecosystem is XCMP, right?
Yeah, exactly.
And I was wondering, what was the rationale to choose IBC as a transport layer instead of XCMP?
Yeah, so the idea is actually that we're able to integrate with multiple different transport layers. So we're intending for basically IBC and XCM to be, actually, I'm trying to find that slide. Anyway, it's on one of these slides, basically. But essentially, we're creating what's called an open transport protocol. So Nomad, Connext, Layer 0, Wormhole, IBC, XCM. These are all the types of transport protocols that can be plugged into OTP for XCVM usage. But to answer your question, why are we also focusing on bringing IBC to multiple different ecosystems as opposed to XCM? First of all, I think it's, bringing IBC to multiple ecosystems is basically, IBC was built for that. IBC was created with the perspective that this transfer protocol would leave the Cosmos ecosystem, as opposed to the initial architecture for XCM, which I think at some point XCM will also be at this stage, which is something we could revisit.
Thank you for your talk. Besides cross-chain interactions, do you see any other strategies to scale DeFi services that maybe technically would be maybe less challenging and maybe other scaling techniques, basically?
Yeah, I think there's some really obvious basic ones, like monitoring, right? Just being a trader and just knowing what's happening to your position would be nice. And then I think also the second thing is just having applications, you don't necessarily need to build a cross-chain application to provide your user with a nice UX, right? So you could build something interesting on ETH mainnet that just makes Uniswap v3 look as stupid as physically possible, and you just execute it through that way. I just think that it does the user a disservice by not building a cross-chain application, simply because you're leaving out the opportunities and the potential additional depth and additional potential entry points to other ecosystems that they could have by just offering them a single application with a single backend and a single set of smart contracts. And that's, I think, one of the major things that we're seeing now is cross-chain applications beget user adoption because of enhanced user experience, but it's a user experience that's also cohesive in nature. Yeah, thank you.